Number 3 continues with section 4.7 on optimization. So it says a fence must be built around a rectangle with an area of 1960 square feet, and one side of the region is next to the water, so we don't need any fence. Material for the two ends cost $8 per foot and $10 per foot for the side opposite the water. Find the least expensive cost for the entire fence. So I'm going to call this X on the sides, and Y is the one that's parallel to the water. Now, in many of these questions, in most of these questions, we're actually going to have two different equations, and only one of them they're going to ask us to maximize or minimize, because again, this is an optimization section. We are trying to maximize or minimize something. So here in the last sentence they say find the least expensive cost for the entire fence. So it's the cost that I'm trying to minimize. So my cost equation, I have C is equal to, and I know that it cost $8 per foot for the ends. So that'll be 8x plus 8x, and then it costs $10 for the side opposite the water. So that'll be plus 10y. So if I combine that, then C is going to be equal to 16x plus 10y. Now, a big issue with this is that I only want to have x's or y's. I only want to have one variable. So I have too many variables here. So I need to find a second equation which will help me figure out how to get this in terms of just one variable. And that would be the area. So if you look at the area, they say that the fence must be built around a rectangle with an area of 1,960 square feet. So I know that whatever x is times y, I don't know what x and y are, but I know that if they get multiplied, they need to be equal to 1,960. So I can actually solve this for y, and y will be equal to 1,960 over x. And this is going to help me out with my too many variables. So I can actually use this to substitute in for y in the C equation. So C is equal to 16x plus 10 times, and then instead of y, I'm going to plug in 1,960 over x. So now my equation only has x's instead of an x and a y. So this is something that I can use with the derivative and then find critical numbers and so on. So I do want to simplify this a little bit more. C is equal to 16x plus 19,600 over x. And then I'm going to actually bring that x up, so C is equal to 16x plus 19,600 x to the negative 1. And this is what I'm going to call my original equation. I mean, we've done a lot of work to get this equation, but we haven't done anything with derivatives or critical numbers or anything like that. So this is our C. This is the equation that we're going to be dealing with. So I do want to take the derivative. So C prime is equal to 16 minus 19,600 x to the negative 2. And then I want to set this equal to 0 to find the critical numbers. So when I do this, I'm going to have 16, and I do want to express it as 19,600 all over x squared equal to 0. And I'll call this 16 over 1. So it's going to help to write these as one fraction. So I want to get the same denominator. So I can just multiply the left one by x squared over x squared, and then that will help me combine my two fractions. So I'll have 16x squared minus 19,600 all over x squared is equal to 0. So if you look at the top, then I have 16x squared minus 19,600 is equal to 0. So if you move the 19,000 over, we get 16x squared is equal to 19,600. If we divide both sides by 16, x squared is equal to 1,225. And then if you take the square root, then x is equal to plus or minus 35. For the bottom, we have x squared is equal to 0, so x is equal to 0. So my critical numbers are negative 35, 0, and 35. And I'm going to cross out, the 0 is actually undefined in the original, which means it actually can't be a critical number. So if you actually want to cross it out first, you can. The negative 35 is a critical number, but it doesn't really make sense for dimensions in the problem, so I'm going to cross that out as well. So 35 is really the only one that makes sense. Okay, so before we actually talk about the minimum, we do need to do a minimum proof. So if you put 35 on the number line, and then plug in test points for the derivative. So if you have y1 equal to the derivative, you'll get negative and positive, which proves that 35 is a minimum. So this is the min proof. Without this proof, we don't know if this critical number, if it's a maximum or a minimum, or if it doesn't change signs at this point. So this is a proof that you should put here. You do need to put this. So my minimum is at 35, which is my x value. And if you plug that back into the original problem, you can get what C is, which is 1,120. So the actual question is asking for find the least expensive cost for the entire fence. So they want just the cost. So this will be 1,120 is the least expensive cost. Now they didn't ask for the dimensions, so you don't need to put it, but if they did, so if they had asked for the dimensions, we already have x, that's 35. If you go back to your y equation, if you plug in 35 there, then you can get 56 for the y. So my dimensions are actually 35 feet by 56 feet. Again, they don't ask for that, but it's possible on a similar question that they might ask for that. Okay, so that's definitely a long problem. Don't forget to like, comment, and subscribe.